welcome back, exclusive Tutoring San Diego students. What I want to do for you guys here is we're going to continue through the rest of these questions. If you had questions of how to get to this link is provided for you guys. But if you just looked up AP Calculus PDF or AP Calculus past exam, you should be able to find this page on the AP Central website. Keep in mind, we're in the free response questions. We're doing the free response here. If you do want to, you can always go in through here, look at additional things about it. I'm going to go through, try to go through everything that we can. But here, we're going to get right into question number 2. If you didn't get a chance to go over number 1, go into our channel. It is available. We did go over how to get these answers and how to make sure we get all those points. All right, next. Okay, number 2. Let f and g be the functions defined by this. Okay, here's your first. Draw this out. Here's your first equation. Here's your second equation. The graphs of f and g, shown in figure above, intersect here, okay? Just so you also know, they did not label this, but you should kind of be able to tell which one's going to be your ln. That's going to be this one above it, right? Because that's going to be the one that kind of levels off over time, and that's what ln and that function does. On the other hand, what you also have is you have this fourth power, right? Fourth power has this a little, almost kind of a W shape, you can imagine, right? 1, 2, 3, 4 in terms of zeros that you could get. But here, let's keep that on there. Here's our 2 equations, and you can almost tell, like right away, they're very likely going to be looking for area between 2 curves. That's the first thing that comes to my mind right here. Find the area of the region enclosed by this graph, right? Graphs of FG shown figure above intersect. Okay, let's make sure we understand intersects at this -2 and x is equal to b. They didn't tell us that. All right, where b is greater than 0. All right, find the area of the region enclosed by the graphs. Okay, we're gonna have to do the integral, right, from -2 to b of top, so f of x minus g, right? That makes sense. Now, don't forget, what is a common mistake? What is something that a lot of students forget is this dx at the end, okay? Real quick, let's just pull up this so you guys see that. Okay. Oh, real quick, we do have to find b. It's not just finding the equation here. So what we're going to do here is we're going to set them equal to each other, use the calculator to determine what x is going to be there so we can plug that in. Okay, so in this situation, they found that for us here. B is 0.7819. You can notice here, that's about right too. It's not quite at 1, right? 0.77819, right? So that's our B. Now with that being done, now we can go ahead. This is the equation I had written. Okay, f of g, or f of x minus g of x, top minus bottom of our equation. That b gets plugged in there, and they find this number, which is 3.604,603. Now, really quickly for you guys too, do not forget that they ask you to give 3 places after the decimal point. So you'll notice down here, they actually will accept whether you rounded it correctly or not, okay? And as a result, okay, that's 1 point for setting up this, right? Setting up the limits of the integration, but another point for getting that b as well. So technically, mine would have missed out on that. If I just wrote this first equation, you'll notice I actually get a part of the point. I'll get a point here for the integrand, right? But the limit not being found would have lost me a point. So I'm going to be starting out behind on this test if I don't get every single part of it. And then the answer. Keep in mind, if I didn't have the B, I wouldn't be able to find the answer, right? I kind of skipped a little bit into this too quickly, trying to get through them too fast. So again, we got to make sure we do this, right? Find the area of the region. They're asking for the actual numerical value, not just the equation. But the equation is essential to get it. So therefore, you're going to be asked for, more than 1 point. This is worth 3 points, okay? Let's continue. For these bounds, right, which are what we're looking at, okay, let h be the vertical distance between the graphs. All right, vertical distance. Is h increasing or decreasing at this value? Okay, so the vertical distance. So now what we're doing is we're measuring each of these at each point. That makes sense? So you could think of it as f of x minus g of x, right, at that exact point. So this is still, when you look at this is still a part of your, a part of your equation for, area under the curve, okay? Is h increasing or decreasing at x is equal to negative 0.5? All right. Now, this is hard to tell because here you have a slope here, you have a slope here. So if you can think about it, is this getting bigger or smaller? We're comparing the slopes at this point. That makes sense, right? We're comparing the slopes to see if that slope added together for these two ends up, widening or increase, or narrowing, okay? Now, let's say this value, this slope is a 1, okay? And this bottom one is a 0. So the slope, it's, as we continue, we got to compare. If this gets smaller, right? If the slope gets smaller than 1, or if this one gets bigger than 0, and that value will start to narrow. On the other hand, if the slope gets bigger and this slope gets smaller, right, it widens. So what can you think of here that's important is we got to understand that we're looking for the distance from each other, right? And that's exactly what we're looking for. Is we're going to put together that absolute value, right? Other form in a definite integral, finding that absolute value to determine, let's see, oh, that's right here. Okay, absolute value. We're considering the derivative, right? And that's where we go find the derivative of them and plug in those values. In this situation, we are given, go back to the other page, we are given the actual values. So we're going to be plugging in and find the derivatives, plug in that for x. So f prime of 0.5, negative 0.5. Okay, and we have g prime of negative 0.5. Keep in mind, you have your calculator, so you could plug them directly in, and then you have your values, right? You have your two values. Pull them up from here. Your two values added together give you this negative number. Now, what does the negative number mean? It means the slope is getting smaller, right? The slope is getting smaller. And so that's what we're going to say is it's going to get a decreasing value as it continues from that point, at that point, okay? So right here, 0.5, it's going to get smaller because its slope is getting smaller. Got that? Okay. C, region enclosed by it is the base of a solid. Okay, so now keep in mind, this is what we do as cross sections, okay? Cross sections. Cross sections, now this is the base, okay? Cross sections of solid are squares. Well, so if this was, you can imagine if this graph was sitting on the ground, right? You drew this on a piece of paper. And now what we're trying to do here is we're trying to draw or from, have squares come up, but the squares, they're not going to be, that's a square, right? the base of it, and as you draw these out in between each other, you start having this shape that you can imagine. It's almost like building these little buildings on top of this graph on the ground, okay? The graph is like the footprint. Well, what that means is you have your original F minus G equation, which is going to give you the area down here, right? That's a square type of situation when you think about it. That's area on the ground. Then what we're going to do is we're going to square that value to find this area. That way it becomes volume as a result, okay? So our equation, don't forget dx at the end of that, -2 to that b that we found. Find the volume of the solid, plug those into your calculator, and you should have that answer. So let's look at that real quick, right? Take the equation, square it, that's what we're doing now. Same, right? Get our value in the volume of that solid is that. So the integral is worth a point, the answer is worth a point, okay? Then our last thing here, vertical line in the XY plane moves from left to right along the base of the solid, okay? Described in part C. Vertical line on the XY plane. So vertical Y line, up and down. Travels from left to right, okay? Right, left to right. That's how it's traveling, but this cursor, right? 7 units per second. That's a rate, that's a derivative. Let's call that R prime, right? Rate of change of the area of the cross-section above the vertical line with respect to time when the vertical line is at position. Okay, wow, that's a lot. But keep in mind, we have all the information here that we need. We're sticking to this equation, right? So we have our -2 to b f minus g squared dx. Let's start off by understanding that this is the area for this, okay? Now, we also understand it's moving at a constant rate of 7 units per second, okay? 7 units per second. In that situation, it's moving left and right, okay, to find the area of this, okay? So, real quick. We start with our area, okay? And what we're doing here is we're finding the rate of change of it, okay? That's why we're finding the derivative of this area, right? dA dx. And then with respect to time, we now have time as our equation. So find the first derivative, plug in that value. Then it gets multiplied by that 7, which is the units per second, because now we can change it from units to the seconds. And that gives us the final value, and the cross-section of our line is moving at that many square units per second. Keep in mind here, there's another 3 decimal points. They will accept if you don't round, but keep in mind, just round it in terms of, greater 5 and greater. And this is a 2-point question. It actually, you got to keep in mind, it seems like a complex one that you could have more, but even just getting this equation together, right? Finding the derivative of it is the first step, and then making sure that we go ahead and do dx dt, which is the constant rate. Okay. Another hint on D is the fact that they have units per second, right? But we're looking for area units, square units per second. So we have to take the units per second and change it into the area, right? We're taking a line that's moving left and right, and we got to figure out how to figure out the 3D version of it. Therefore, it is going to be related by changing what we're measuring in respect to. Okay, that's gonna be number 2. And try to keep these all short and sweet. That was just the end of part A. We do have additional questions coming up. These additional ones do not have calculators, so you will have to calculate these by hand. But again, we're going to go through and show you how, the calculator section's a little bit more fluid. You have to get your answers. You have to have them rounded to that third decimal point. But on the other hand, with the part B, these questions that you get are going to be more focused upon whether or not you can write out the equation and write out the formula for how to define it, how to find it. Finding the actual answer is still just going to be 1 point. So keep in mind, if you know how to do these things and you're not so confident with your calculations, it's still possible to pass this test. But you got to just make sure, if you're good with showing your work, that you show all of it here so the grader can find those parts of it and give you credit. Okay, that being said, I will see you guys in the next video, and we'll continue with these AP calculus questions. Have a good one, guys.